Hello, friends. Okay, so hello, friends. Welcome to my channel, Maths Corner. So, my name is Swamin Pitlia. I welcome all of you to the amazing series and the amazing video. So, here we are here with the proof of why the area of circle is pi r square. Now, you might be studying from class 6 that the area of circle is pi r square, pi r square, pi r square, but none of you tell that why it is so, and you are not capable of proving that thing. So, today I am here with you to prove that why the area of circle is pi r square. Okay, so let us start with let me see that if the voice is clear or not. Okay, so it's clear. So let us start with the. Before moving to that thing, I will need you that you must know some two important things. First thing is the integration as the area under curve. What you must know some basic idea about integration, and the second thing you must know is an equation of circle. Don't worry if you don't know. I will tell you that thing, both the things I will tell you before the proof. So first of all, let us move to integration as the area under curve. So what is the integration? You must know that integration is just a reverse process of differentiation, but the integration is also regarded as the area under curve. Suppose I have a curve that's for I'm assuming the curve to be y is equals to x. Okay, so y is equals to x is my curve. So I have to find out the area under this. So what is the curve that I can draw that y is equals to x? So this is my x-axis, y axis, and this is my y is equals to x. None of you will find out this area using integration. All of you will just make a triangle and find out the area. But you can find out this area by integration also. Okay, suppose this is my area. So how can I find out? I will just integrate this. My function is y is equals to x. So area will be integral x dot dx. It will be x square upon 2. It will be x square upon 2. So you can prove this by making triangle also. As y is equals to x, suppose at a distance x, this is my x, and if this is my x, then as the curve is y is equals to x, so this will be also my x. Now the area of triangle is half base time height, so it's half x into x, that is x square upon 2. So it's a basic idea about area under the curve. So you can choose any function and draw its curve and find out the area using integral. I am assuming that you know some basic integrals. That is integral sine x, integral cos x. You must know, and integral of sine 2 theta, integral of sine 3 theta. That I will tell you. So this is the concept of integration as the area under curve. Okay, now let us move to our next thing. That is the equation of circle. How can we derive an equation of circle? First of all, let us understand what is the equation of circle. As this was an equation of a line y is equals to x, as the any equation of line is of form y ax1 plus by1 plus c is equals to 0. So it is a basic form of equation of a line. There is a basic form of equation of a circle also. Okay, so what is the basic form? Suppose this is my circle, and this is, I am assuming this has my origin 0 comma 0, and I am assuming any point on a circle. Let's say its point is x comma y. Now the distance between these 2 points is always r. Okay, the distance between these 2 points is always r. So I can use the distance formula here. I can use the distance formula here to get under root of x minus 0 whole square. That is x square, and plus y minus 0 whole square. That is y square. This thing is equals to the distance between these 2 points, which is my r. And this thing is equals to r. So I will do the whole square on both sides to get x square plus y square is equals to r square. Okay, so this is the basic equation of a circle. Okay, so what is the equation of circle? It's x square plus y square is equals to r square. X square plus y square is equals to r square, where r is the radius and x and y are the coordinates of the point that is lying on the circle. Okay, So this much tools we are required to prove the area of circle. Okay, now let us move to the proof. Now this is my circle and I've divided the circle into four parts, or I can say that each part is of one quadrant. So I divided the circle in four quadrants. Now, as this two lines, my x-axis and y-axis is passing through the center, so I can say that these two lines divide the circle in four parts which have four equal areas. Now, if I am able to find out the area of a single part, that is a single quadrant, then I will just multiply that quadrant area by 4 to get my area of circle. Now, my full focus is on on to finding the area of quadrant. This is my quadrant. As my full focus is on finding the area of this quadrant. So how can I find out? Uh, so this is my radius and this is my radius r. Okay. Now I will use some concept of integration here. I will just take a small element. I will take a small element. This is my small element. This is a very small size. Okay, so this is my small element, and its height will be, let's say its height is y. So as it is moving away from the center, its height will gradually decrease only. Okay, so this is my y, and this is my small, let's say small width. Let's say it's dy. Let's say it's dy. So the area of this strip, the area of this element that I have chosen will be obviously behave as a rectangle, and it will be y dot dy. Okay. Now this will be of this. I have taken a small strip. Now I will take one more strip here, one more strip here, and the number of strips, let's say n, it tends to infinity. The number of strips tends to infinity because I will take as much as small as this strip length is possible. So very small strip length is possible. So I will take, so there will be infinite strips that I will take, and that will be covering from y is equals to 0 to y is equals to r. Okay, as my this distance is also r, my this distance is also r. At this point, if I take this strip, then I will take this strip. So at this strip, if I tell this strip, at this strip, y is always, I can say y is 0, and at the longest strip, the y will be my r. So I will just integrate the y dot dy from y is equals to 0 to y is equals to r to get my the area of this quadrant. So it will cover all the strips that are running from y is equals to 0 to y is equals to r, and it will cover the area, full area, and I will get the area of quadrant, and I will just multiply the area of quadrant by 4 to get the area of circle. So let us do it. So what I have to do is I have to integrate y dot dy. I have to integrate y dot dy. I will put the limits afterwards. Y dot dy. Now I will not remain this y as y. I will do one thing. I will take an expression for y in terms of my r and x, where r is the radius and x is x coordinate. Okay, so from my equation of circle, my equation of circle is x square plus y square is equals to r square. So from here I can write down that y is my under root of r square minus x square. Just transferring and doing the under root both side. My y is under root of r square minus x square. So I will substitute the value of my y in my the integral value. Now, as I am now variable has changes from y to x, as the variable changes from y to x, the dx should be replaced, dy should be replaced by some dx term. So if I differentiate this term, okay, if I differentiate this term, I can get out an expression for dy. If I differentiate this term, that is 2x dot dx, so I will differentiate this, so 2x dot dx plus 2y dot, I can write down something else. I am differentiating this in terms of x. Okay, it will be simply 2x. It will be simply 2x, 2y into y dash. This thing will be my differentiation of r square, which is a constant. Radius is constant, so this will be my 0. Okay, so this is I am differentiating this. Okay, so what I will get is, what I will get is I will use this thing here, so I will get out this to be integral y. It will be under root of r square minus x square. Now dy will be changed to dx. Now I have to find out this integral. I have to find out this integral. But the problem here is the under root. So you must know some general substitutions of integration. That when this type of format is used, when this type of format is being asked, you just substitute the value of x. Just substitute the value of x as r sine theta. You substitute the value of x as r sine theta. Okay. Now, if you substitute the value of x as r sine theta, what the good thing you get is it will become x square will be r square sine square theta. Taking r square as common, you will get 1 minus sine square theta. And under root of r square into 1 minus sine square theta. As 1 minus sine square theta is cos square theta. So I will get the under root of r square cos square theta, which is r cos theta. So the under root thing will get removed, and I will be able to solve using some basic integration. But the dx should also be removed, as I now I will be putting the limits of theta. So I will differentiate this thing to get in terms of dA, and I will differentiate this in terms of theta. So dx upon d theta will be, as r is constant, r differentiation of sine theta with respect to theta, which is obviously cos theta. So from here I can get out that expression for dx. My dx will be obviously r cos theta dot d theta, r cos theta dot d theta. I will just put the value of dx in my this thing, and I will just also put the value of x as r sine theta in my expression to get a very simplified expression. So that will be integral r square minus x square, which is r square minus r square sine square theta. It is taking r square, I will take as common. I get 1 minus sine square theta, and the dx will be r cos theta dot d theta. So it will be r cos theta dot d theta. Okay. Now this thing I get. Now this thing is r square 1 minus sine square theta. 1 minus sine square theta is cos square theta. Basic trigonometric identity. I will substitute the value here to get r square cos square theta, and the under root of that thing is r cos theta. So it will be integral r cos theta is obviously is already there in outside the under root. So r cos theta into r cos theta will be r square cos square theta. R square cos square theta dot d theta. Okay. Now what I have to do? My cos square theta. Now I doesn't know the integral of cos square theta. I can find out the integral of cos square theta by integration by parts. So I can use that integral, but I can also use some basic trigonometric identity else using the integration by parts. So take as r square is constant. So I will take out the r square outside to get it is equals to r square times integral of cos square theta dot d theta. Okay. Now cos square theta dot d theta, this is my integral. How can I do this integral? The first way is by integration by parts. Cos theta into cos theta, and then applying integration by parts. But I will not use that stuff. I will convert this cos square theta in some form of cos 2 theta. How can I convert? That I must know a basic identity, that is my cos 2 theta. My cos of 2 theta is equals to cos square theta minus sin square theta, that is 2 cos square theta minus 1. 2 cos square theta minus 1. So from here I can write down cos square theta in terms of cos theta very easily to get uh, 1 plus cos 2 theta, 1 plus cos 2 theta upon 2 is mine cos square theta. Now I am getting rid of that square term, and I have converted this into my linear term, that is cos 2 theta. So I will substitute the value of cos square theta from this expression, 1 plus cos 2 theta by 2. Okay, so this will be mine integral cos square. So r square is already there outside, r square. Okay, cos square theta, it will be 1 plus cos 2 theta by 2. So this 2 will also get outside because it is also constant. So r square by 2 times integral of 1 plus cos 2 theta and this whole d theta. Now I have to put the limits of theta. Now why what theta? Theta is the angle, and the angle is ranging from here. The angle is theta, and here theta is my 0. Now This is moving theta from 0. So this is 1 degree, 2 degree, 3 degree, 4 degree, 5 degree, and it's 45 degree. Then I get 90 degree. So theta is ranging from 0 to 90, but I will not use 90. I will use pi by 2 as my radian measure. So theta is ranging. This is my 90 degree. So theta is ranging from 0 to pi by 2. That is my 180 by 2. That is 90 degree. This is a radian conversion. So I will put the limits of theta is my 0 to pi by 2. This is my 0 to pi by 2. Okay. Okay. So now I will use this thing. I will derive this thing. I will take the part. I will just by using the basic property of integration, that is I can write down as a integral 1 plus integral cos 2 theta. R square by 2 is now again constant only because this is a constant. I can write down this as integral 1 dot d theta plus integral of integral of cos 2 theta dot d theta. The limits are same. Theta limits are theta is equal to 0 to pi by 2. Theta is equal to 0 to pi by 2. Theta is equal to 0 to pi by 2. Now, what is the integral of 1 dot d theta? It is just theta only. It is just theta only. So this is my theta. Range is I have to apply the limits, that is 0 to pi by 2 plus what is my integral of cos 2 theta. Now this is an confusing thing. No, so don't confuse between that integral of cos 2 theta as the integration of cos x is sin x. So integration of cos 2 theta is sin 2 theta. That is not same thing. So integral of cos 2 theta, integral of cos 2 theta is 1 by 2. That is 1 by 2 times integral of cos 2 theta, that is sin 2 theta, plus a constant c. Plus a constant c. That I will ignore that constant here. Okay. So integral of cos 2 theta is 1 by 2 sin 2 theta. Okay. So I have to divide by the differentiation of my angle. In my differentiation, I was multiplying by using chain rule, but I have to divide the differentiation of my angle of my function in this 1 by 2 sin 2 theta. So I will just substitute the value of integral of cos 2 theta 1 by 2 sin 2 theta. This is my plus 1 by 2 sin 2 theta. Again 1 by 2 as a constant. 1 by 2 sin 2 theta. 1 by 2 sin 2 theta. Theta is ranging from 0 to pi by 2. Now this whole thing is being multiplied. Is not thing is not alone. This whole thing is being multiplied by r square by 2. Don't forget this thing. Now just evaluate this thing. Now theta, just put pi by 2 minus 0. It's pi by 2. Okay, it's pi by 2. So this is my pi by 2 plus this thing half sine 2 theta. So it will be half sine 2 pi by 2, which is sine pi, which is 0, minus sine 2 times 0, which is sine of 0, which is 0. So which is equals to 0. So this thing have a null effect on my value. So as this thing is coming out to be 0 after putting the limits. Okay, so I can get out there's the only this thing is left, that is pi by 2 minus 0, which is pi by 2, and which is being multiplied by r square by 2. Okay, so my integral is coming out to be pi by 2, and nothing is there in plus with this. This thing is being multiplied by the r square upon 2. Okay, so this is my pi r square by 4. This is my pi r square by 4. Now this is not the area of circle, it is the area of quadrant. I've told you before only, this is the area of quadrant. This is the area of one quadrant. There are four quadrants in a circle, as you can see. There are four quadrants in a circle. So I have find out the area of my this thing to be pi r square by 4. So I can multiply this by 4 to get the area of this whole four quadrants, that is 4 into pi r square. So my area of circle will be area of circle will be pi r square by 4 into 4, which is coming out to be pi r square. So it's 4 get cancelled with 4. So I get the area of circle to be pi r square, where r is the radius and pi is our favorite 22.7. So I have find out the area of circle by integrating. I have used this whole thing. I have just done this much of integration, and I get out the area of circle to be pi r square. So I hope you are good at this thing, and you are happy after knowing the proof of area of circle as pi r square. So thanks for watching my video, and don't forget to like and subscribe my channel. This video also you have to like and subscribe, and hit the bell icon to get the latest notification of my videos. Thanks.